Okay, saying hey from West Virginia. I'm saying hey from somewhere, I'm just not sure where. But what I am sure of is I have joke of the day, and I know that you're waiting for joke of the day because it is the best part of the day, so let's get to it. All right, so I was wondering why the baseball was getting bigger, and then it hit me. And joke of the day, the best part of the day. I love joke of the day. It's awesome. Okay, so the other awesome thing is being able to multiply fractions. We are now going to take a look at multiplying fractions because we know how to add fractions. We know how to subtract fractions. We are now going to take a look at how to multiply fractions. What you need to understand is that the word of in math always means multiplication. Always means multiplication. Now, there's a huge difference between the words out of and strictly the word of. And when you see just the word of, not out of, but of, you should be thinking multiplication. So what we're going to do is we're going to work through these examples, and in working through these examples, that's going to get us to the steps. We're going to figure out the steps. We're going to derive or come up with the steps for our multiplication of fractions. So let's take a look first at this one. Now, there is a multiplication symbol right there, 3 times 1/4. But remember, I said that in math, multiplication, the word of, they go hand in hand. They mean the same thing. So I can read this as 3 times 1/4, or I can read it as 3 of these 1/4 pieces. 3 of these 1/4 pieces. Well, I've got 3 of these 1/4 pieces sitting right here. So when I put these 3 pieces together, what I come up with is 1, 2, 3, 3/4 as my answer. So 3 of these 3/4 will give me 3/4. In other words, 3 times 1/4 will give me 3/4. Now let's take a look at the second problem, and we'll even look at all 4 of these before we come up with our steps. So the next problem, notice it says 3 times 1/12, but remember, we're going to think of it as 3 of these 1/12 pieces. Well, I've got 1/12 pieces right here. Here's all 3 of them. I'm going to put them together. And so that gives me 3 of these 1/12 pieces. In other words, 3/12. However, check this out. Those 3/12 pieces have the equivalent space as this 1/4 piece. And we did look at the idea of simplifying fractions, and we said that when you simplify fractions, you look for the same number that will go into the numerator and the denominator, and a 3 will go into both the numerator and the denominator. 3 goes into 3 once, 3 goes into 12 4 times, leaving me with the 1/4 that I just mentioned. So let's take a look now at the next 2. And so 1/4 is going to be my answer here. And up here, my answer is going to be 3/4. Now, let's take a look at the next 2, and then we'll come up with those steps. Notice the next one says 1/2 times 1/4. Or we could read it as 1/2 of the 1/4 piece. Well, if I take this 1/4 piece right here and I do half of it, notice what's left here. When I do half of this 1/4 piece, I come up with the equivalent of 1/8. It has the same space as this 1/8 piece. So in other words, this 1/2 times 1/4 is going to be 1/8. Now, let's take a look at the last problem, and like I said, we'll come up with our rules once we get there. So this one says 1/3 times 3/4, and the way I'm going to read it is 1/3 of these 3/4. Well, notice here's my 3/4 right here, and if I want 1/3 of them, that means I want to break this up into 3 sections and I only want one of those sections. So if I take these 3/4 and I break it up into 3 sections and I only want one of those sections, then that means that 1/3 of these 3/4, or in other words, 1/3 times 3/4, will give me a 1/4. Now, I don't know about you, but I do not want to have to carry these magnetic pie pieces around with me everywhere I go in order to multiply fractions, nor do I want to have to draw these pieces everywhere I go. Now, they're certainly fun. I really like that they stick to the board. These are really cool. But I don't want to have to use them every single time I need to multiply fractions. That's why I need these steps, so that I can come up with the generalization, so that I can do this potentially in my head. Well, let's take a look at what happens here. You'll notice that when we compare this 3 and this 1/4, it looks like perhaps we just go straight across. And in fact, if I take that 3 and turn it into a fraction, I would put it over a 1. And then sure enough, I do multiply straight across. 3 times 1 is 3, 1 times 4 is 4. Aha! So that is one of the steps for multiplying my fractions. It's actually the second step of multiplying those fractions, is I'm going to multiply across numerators and denominators. Across numerators and denominators. Now, let's check and see if that holds true for all the other problems. Notice again, if I put that 3 over a 1 in the second problem, and I multiply straight across, yes, 3 times 1 is 3, 1 times 12 is 12, I do get that 3/12. However, and do notice that that does happen down here. Multiply straight across, 1 times 1 is 1, 2 times 4 is 8, it's working. But in this problem, when I multiply straight across, I'm going to get 3, and when I multiply straight across here, I'm going to get 12. But, as we said before, 3/12 does simplify to 1/4. However, notice here, I wanted to get there in one step. And quite frankly, could I get to this answer in one step? In fact, I definitely can. And that actually is the first step for multiplying fractions. Check this out. What I want you to do is I want you to go back to elementary school. The first time you ever learned what multiplication was. Now, the multiplication symbol that I'm using here is a dot, and at this upper level we use dots for multiplication. But in elementary school, what was the symbol that you used for multiplication? Yeah, an X. So I want you to make an X. I know you feel kind of silly. You're like, I'm watching a video. Do I really need to make this X? Yes, you really need to make the X. Make the X. Just make the X. You're going to find out that you are nowhere close to as silly as I am. You watch enough of these videos? Oh yeah, I'm the silliest thing, way sillier than you. So anyways, make your X. Now what you have done is you have created diagonals. And so therefore, when you multiply fractions, and the X is for multiplication, when you multiply fractions, you're going to cancel on those diagonals. And see, that's exactly what's happening in this problem. When I look at these diagonals and I try to cancel on them, what's going to happen is I'm going to say, oh, you know what? I can divide a 3 into both of these numbers. 3 goes into 3 one time, 3 goes into 12 4 times, and now check this out. Now if I multiply across, 1 times 1 is 1, 1 times 4 is 4. I was able to get there very quickly, more importantly, without the need to simplify or reduce my fraction. Let's see if that holds true on this one. Once again, X for multiplication. So I'm going to cancel on those diagonals and I'm going to see what happens. So I'm going to say, okay, a 1 and a 4, there is nothing that will divide into both of those. Both of them are only divisible by 1. That doesn't help. But when I look at this diagonal, oh yeah, 3 goes into 3 once, 3 goes into 3 once, and now, check it out, 1 times 1 is 1, 1 times 4 is 4, aha, there it is. So that first step is actually to cancel on the diagonals. Now though, I do need to show you something else, because it isn't just canceling on the diagonals. Let's take a look at another example. So in this example, what it says is I want a third of these 6/12. Well, let's get 6/12 up there. I've got 1, 2, 3, 4, and 5, 6. Oh, there we go, 6/12. But notice that 6/12 has the same space as 1/2. So 6/12 is the equivalent of 1/2. More importantly, notice this, that when it says I want 1/3 of these 6/12, 1/3 of the 6/12, remember that means I'm going to break this up into 3 sections. So here's a section, and here's a section, and here's a section, and I only want one of those sections. So I only want one of these sections, which is right here. But check this out, that 1/12 is the equivalent of 1/6. So in other words, when I multiply 1/3 times 6/12, I get 1/6. But let's go back to that rule that we discovered. We said we're going to cancel on those diagonals. So nothing cancels here, but notice there is some cancellation that I can do right here. 3 goes into both of those. 3 goes into 3 once, 3 goes into 6 twice, But see, now when I multiply straight across, 1 times 2 will give me 2. 1 times 12 will give me 12, but I need to simplify that fraction. So the idea of simplifying the fraction is the idea of canceling up and down. So not only do I cancel on those diagonals, I as well cancel up and down. So as you look at this up and down right here, notice that 2 will go into both of these because I end up with 2/12 right there, which we said 2/12 simplifies. So I'm going to go ahead and cancel up and down, and when I do, 2 goes into 2 once, 2 goes into 12 6 times, and now what I've done is I've canceled on the diagonals, I've canceled up and down, and now I'm ready to multiply straight across, or as I say, shoot straight across. So I'm going to multiply straight across here. 1 times 1 is 1, 1 times 6 is 6, voila, there it is. So see, that first step, like I said, quite frankly, it really should not just be canceling those diagonals. It should also say cancel on the diagonals and up and down. Include that up and down. And the reason you do that is because I can 100% guarantee to you that if you will cancel on the diagonals and cancel up and down, then I promise you that when you multiply straight across, or as I like to say, shoot straight across, then what's going to happen is your fraction, your answer will be simplified. 100% guaranteed it will be simplified. You won't have to think about simplifying it. And while it wasn't that difficult to simplify 3/12, and while it wasn't that difficult to simplify 2/12, what if your numbers get enormous? Oh no, my set's falling apart. What if, step back a second. What if your numbers get enormous? If they do, then I don't want to have to multiply across here 7 times 24 and get this enormous number, 12 times 35, get an enormous number, and then try to simplify that enormous number. What I'd rather do is work with the 12 and a 24 because I can easily cancel those out. I'd rather work with the 7 and 35. I can easily cancel those out because these numbers are small. So I want to keep my numbers small rather than just going ahead and multiplying across. What a lot of people do is they multiply across and then they try to simplify their fraction. I'm telling you guys, if you do this, and what happens here is, like I said, x for multiplication, that means cancel on the diagonals, cancel up and down, and then multiply across. What happens is you create numbers that are going to be small to work with, and it makes life so much easier. So let's try that on this last one. And what I'm going to do here is I'm going to, again, cancel on those diagonals. So I'm going to look at that 7 by 35 and I'm going to say, wow, 7 goes into 7 once, 7 goes into 35 5 times. And I'm going to cancel on this diagonal. I'm going to say, wow, 12 goes into 12 once, 12 goes into 24 2 times. Now, what if you didn't think of the 12? What if all you could think of was 6 goes into 12, or even so, what if all you could think of was 2? 2 goes into 12 6 times, 2 goes into 24 12 times. Well, continue to look and say, is there more that will divide into these? And there is. Because at this point I can say, oh, okay, 2 still goes in. 2 goes into 6 3 times. 2 goes into 12 6 times. And I can say, oh, still divisible. 3 goes into 3 once. 3 goes into 6 twice. So I finally did all the cancellation that I possibly could. However, like I said, it's much easier if you try to find the biggest number that will go into both. But just keep on canceling until you can't cancel anymore. So remember, I'm going to cancel on the diagonals, but I'm also going to cancel up and down. Take a look. 1 and 1, nothing cancels. 2 and 5, nothing cancels. So after I cancel on the diagonals and I cancel up and down, what am I going to do? Oh yeah, I'm going to shoot straight across. So I'm going to multiply across here. 2 times 1 is 2. I'm going to multiply down here. 1 times 5 is 5. And voila, there's my answer. And like I said, 100% guaranteed, it is simplified. Because you canceled on the diagonals, you canceled up and down before you shot straight across. So that is my answer. So hopefully this helps with being able to multiply fractions. And now that you know the steps, guess what? You are in my math gang. Because what we're going to do is when we see a multiplication symbol, we're going to, X for multiplication means cancel on the diagonals, cancel up and down, and then shoot straight across. And so now you are in my math gang. That's a fun gang to be in, to be able to do math, isn't it? That's a great way to live. So we are going to cancel the diagonals, cancel up and down, and then we are going to shoot straight across. So I hope that helps. Have a great day.